Hello everyone and welcome back to our channel Quaint Cosmos. Until now detecting gravitational waves required ultra-sensitive laser interferometers stretching kilometers in length like LIGO and Fargo. LIGO and Fargo, they are used to detect gravitational waves. By using Einstein's theory, gravitational waves were predicted in the year 1916, and recently in the year 2015 LIGO was used. LIGO was used to detect that gravitational waves directly. Now physicists are thinking something different. Aim or the purpose remains the same, detecting gravitational waves, but not by these setups like a LIGO or Fargo, which stretches kilometers in length. They are trying to use a new theory. Just by using magnets, they are trying to detect gravitational waves. Yes, they are trying to use magnets. That means a new principle is required, and they have found such a principle. They have found that when a gravitational wave passes through a magnetic field, when a gravitational wave passes through a magnetic field, it disturbs the charged particles. That means the gravitational wave disturbs the charged particles like electrons. And these disturbance can generate electromagnetic signals. And these electromagnetic signals can be detected by using ultra-sensitive magnetic devices or ultra-sensitive magnetic sensors like SQUIDs. SQUIDs means superconducting quantum interference devices. In short, this is known as SQUID, plural from SQUIDs. So superconducting quantum interference devices. So what is the principle behind this? Principle is that whenever a gravitational wave passes through a magnetic field, it disturbs the charged particles. If charged particles are there, like electrons, and that disturbance actually can create electromagnetic signals, and now you just detect them by using SQUIDs, means ultra-sensitive magnetic sensors, and that way you should analyze and you can tell something about gravitational waves, means you can detect gravitational waves. Because research is ongoing in this field. They are trying to analyze, not just detecting, they are trying to analyze the detected gravitational waves to know many things about the universe that is known to you. So gravitational waves were predicted by Einstein's theory in the year 1916, and that was detected for the first time by using LIGO in the year 2015. There is a gap of 99 years. Anyway, right now physicists are trying to do this thing, and in current experimental setup they have been using this principle using ultra cold and noise isolated environments. In their recent experimental setups, physicists are using this thing. Ultra cold and noise isolated, because noise isolation is required, otherwise that could mimic, if noise is present, that could mimic gravitational waves. That's why isolation of noise is required, and sensitivity of the instrument must be increased. So maybe these new devices, still it is in the early stage of development. Physicists are trying to design such systems using this principle. So in that case, what could happen? Either the new devices would complement the existing devices like LIGO and Fargo, or totally could replace LIGO and Fargo. And since they are using magnetic devices, so there is a chance that drastically the size of the devices could be reduced. So in that case, what would happen? Universities would be able to use such small devices. Okay, because I have already mentioned that the length of the or the size of the LIGO and Virgo, those devices, those observatories, stretches kilometers in length, and you can easily guess that such a huge device cannot be used by any university, any institute. That should be separately done at a separate place. So many advantages are there. And if bandwidth means if you increase the sensitivity of these new devices, magnetic devices, then in that case more bandwidth can be captured by using such new devices. So we would be able to explore more about the universe, more about the unknown. More about the universe means more about the unknown, because most of the universe is still unknown to the physicists, still unknown to all the scientists. Anyway, so this was all about today's topic. Okay. If you found this video fascinating, so please like, share and subscribe to our channel. This is the end. Thanks for watching.